Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at some simultaneous equations. Okay, this is a new topic for us, new topic, GCSE topic, but it's a new topic for these videos. So we're going to proceed as if you've never even heard of a simultaneous equation before. If you have, if you're happy with them, just move on, skip the video. But if you've not seen them before, if you've forgotten them, if you're not very comfortable with them, stick here and we will be doing some simultaneous equations. Okay guys, so what is a simultaneous equation? Okay, again, we're just going to assume that no one knows anything about them, other than myself, obviously, because otherwise that would be dangerous, guys. That'd be so bad if I didn't even know about simultaneous equations. So, what is the definition of a simultaneous equation? A simultaneous equation, or a set of simultaneous equations, are two or more equations. You can potentially have an infinitely many simultaneous equations. In the A level, we normally just have two equations, okay? And to solve these two simultaneous equations, you need to find values for the unknown variables. So normally those are x and y's, which I've written here, but they can be other things. You know, you could see t's, you could see u's, you could see p's, q's, any letter potentially. And those values have to satisfy both of the equations, okay? Or if you have more than two equations, all three or all four or all five of the equations, in order for that to be an actual solution, okay? So let's just actually put some numbers on the board. Let's actually graph what we're doing, because these simultaneous equations, they are graphs, okay? That's something really important to know. It's a graph, okay? So this, for instance, here is an example of a simultaneous equation. This says 2x plus 3 equals 8 and 3x minus y equals 23. Okay, so if you were trying to solve, let's just look at the top one, okay? If you were trying to solve 2x plus 3y equals 8, you could find lots and lots of values for x and y that satisfy 2x plus 3y equals 8. But you're looking for one value for x and one value for y, and you can't do it. You can't just solve that. Right? You can solve it for x as a function of y, you can solve it for y as a function of x. You can't actually find definite values for x and y if you only have one equation, because there are two variables, x and y. They are not constants, they are actual variables, okay, so they can change. Now, with the help of a second equation, we can actually cross-examine the first one, and we can almost use the definition of the second one in order to allow it to tell us something about the top one, or vice versa, whichever one is easier. So normally in A-level maths, there are two methods to solve these things. There is substitution and elimination. Now, there are many methods to solve simultaneous equations. For example, you can use something called a matrix to do it as well, but you will not do that in A-level maths because they're not in A-level maths. However, if you're going to do A-level further maths, they are in that, okay? Just something to notice. So I will proceed to make two videos, one on solving this is a linear simultaneous equation. It's linear because these each make a straight line. Do you see that? So they are linear simultaneous equations. They will only ever, a linear simultaneous equation, that means a simultaneous equation which does not have things being squared or cubed or whatnot, just straight lines. They will only ever have one intersection, which is this point here, for example, which means there will only ever be one solution to that simultaneous equation. You can't have two. You can't have two different x values or two different y values. You only ever get one. So yes, I will make a video on substitution and elimination, and then we will proceed to look at things like quadratic simultaneous equations as well. Okay. So just taking a look at this very quickly in this video, you might be a little bit confused. Hold on, why is this the line of 2x plus 3y equals 8? And why is this the line of 3x minus y equals 23? Hold on a second, that's not right, because lines should be in the form y equals mx plus c. So some gradient m times x plus a constant, okay? That's not in that format, so what are you talking about, Elliot? Well, let me tell you something. 2x, oh, this is an awful pen. 2x plus 3y equals 8, yeah? That's what we've got up here. Rearrange. Let's take 2x away from both sides. 3y is equal to 8 minus 2x. Okay, my pen is, both of these pens are suffering at the moment. Now, we've got 3y, we want 1y, so we're going to divide by 3. So we've got y equals 8 over 3 minus 2 over 3x, okay? And if you really want to sort of be formal about it, you've got y equals minus 2 over 3x plus 8 over 3, okay? I just swapped the orders of this factor and this factor, okay? So this, 2x plus 3y equals 8, is actually the exact same thing as y equals minus 2/3 x plus 8 over 3. And my God, does it look like it is? I mean, that looks to me like it's roughly 8 over 3. Awful pen, guys, I know. So the y-intercept is 8 over 3, looks legit to me. And the gradient, it's negative, isn't it? Because it's going down as x increases, which means it's got a negative gradient. It's a downward slope, but it's not that steep, so it's 2/3 steep or minus 2/3 steep. So it checks out, looks right. And if you wanted to, you could do the same for this one. This is going to be quite a steep one. The gradient's going to be positive, etc., etc. So you can actually convert 2x plus 3y equals 8 into y equals mx plus c with some basic rearranging skills. We will look at this more in chapter 5 of the Edexcel Pearson textbook, which is just straight lines. So when we study straight lines, we'll be looking at converting it between these forms. But for now, take my word for it, basically, a simultaneous of this sort of, that looks like this, I guess you could say, is two straight lines crossing, okay? And this is the sort of geometric idea of a simultaneous equation. The point at which these lines intersect with each other, so I've already calculated, it's 7 minus 2. That's this point here. That's where they cross. This is the x coordinate. This is the y coordinate, of course, which means if you were to substitute x equals 7 where you see an x and y equals minus 2 where you see a y, those values for x and y will satisfy, they will satisfy the top and the bottom equation. They will both be true at the same time. That is what a simultaneous equation is, okay? You need to find x and y values that simultaneously satisfy both equations, okay? It's really easy to find values that satisfy one equation. Satisfying two, it's a different ball game. So there's two methods to do it. So I'll see you guys in the next video where we discuss that.